Let's look at probability problems involving not and or. We randomly pick a card from a deck of 52 cards. Find the probability that we pick an ace or a heart. Recall that a deck of 52 cards consists of 4 different suits: heart, diamond, club, spade, each with 13 different values: ace, 2, 3, 4, 5, 6, 7, 8, 9, 10, jack, queen, and king. You might think that the probability of an ace or a heart is the probability of ace plus the probability of a heart. This would give us probability of ace plus probability or heart. Probability of ace or heart, I should say, is the probability of an ace plus the probability of a heart. In other words, 4 out of 52, because there are 4 aces in the deck, plus 13 out of 52, because there are 13 hearts in the deck. That would give us 17 out of 52. But this is the wrong answer. The probability of getting an ace or a heart is not 17 out of 52. Here's why. Of the 52 cards in the deck, only 16 of them are aces or hearts. You've got the ace of spades, clubs, hearts, diamonds, and then the other hearts would be 2, 3, 4, 5, 6, 7, 8, 9, 10, jack, queen, king. So the probability of an ace or a heart is 16 out of 52, not 17 out of 52, because there are only 16 cards in the deck out of the 52 cards in the deck that are aces or hearts. So this formula that we used earlier is wrong. The probability of an ace or heart equals probability of ace plus probability of heart equals 4 out of 52 plus 13 out of 52 equals 17 out of 52. That's a wrong formula. Why? It's because we double counted the ace of hearts. We counted it under the 4 out of 52 because there are 4 aces in the deck, and we also counted it under the 13 out of 52 because there are 13 hearts in the deck. And so because we double counted the ace of hearts, because we counted it here and here, we got 17 out of 52. Here's the right answer. If A and B are two events, then the probability of A or B is the probability of A plus the probability of B minus the probability of A and B. So in this case, for example, if you want to calculate the probability of A of getting an ace or a heart, you would add together the probability of getting an ace and the probability of getting a heart. But notice when you do that, you double counted this region in the middle. You counted it under ace. You counted it under heart. And you don't want to do that because there's an ace of heart that was double counted. So what you want to do is calculate the probability of getting an ace, calculate the probability of getting a heart, and then because you calculated the probability of getting an ace and a heart, in other words, the ace of hearts, because you double counted that, counted that under both of them, you want to subtract that off so that you don't double count it. So the probability of getting an ace or heart is the probability of ace plus probability of heart minus probability of ace and heart. That would be 4 out of 52 plus 13 out of 52 minus 1 out of 52, because there's only one card that's both an ace and a heart. It's the ace of hearts. And that gives us 16 out of 52, which is the correct answer. We are playing Monopoly. Our opponent has hotels on Park Place and Boardwalk. If we roll a 7, then we'll land on Park Place. If we roll a 9, then we'll land on Boardwalk. In either case, we'd go bankrupt. I know what this is like. Last few times I played Monopoly against my kid, I lost. What's the probability that we roll a 7 or a 9? Okay, here's a review of dice probabilities. If you roll a pair of dice, a pair of 6-sided dice, of course, probability of getting a 2, the probability that the sum is 2, is 1 out of 36. Probability that the sum is 3 is 2 out of 36. Probability that the sum of the dice is 4 is 3 out of 36, etc. So notice the probability that we roll a 7 is 6 out of 36. Probability of 7 is 6 out of 36. And the probability that we roll a 9 is 4 out of 36. Probability of 9 is 4 out of 36. So the probability that we roll a 7 or a 9 is, well, let's use this formula again. If A and B are two events, then the probability of A or B is the probability of A plus the probability of B minus the probability of A and B. So in this case, the probability of 7 or 9 is the probability of 7 plus the probability of 9 minus the probability of 7 and 9. So in other words, you get probability of 7, which is 6 over 36, plus probability of 9, which is 4 out of 36, minus the probability of 7 and 9. And what what is the probability that you roll a 7 and a 9? That is 0. When you roll a pair of dice, you can't get the sum to be both 7 and 9. So we end up with 6 out of 36 plus 4 out of 36 minus 0 equals 10 out of 36. We are playing Monopoly. As we have seen, the probability that we roll a 7 or a 9 is 10 out of 36. We just saw that a moment ago. What is the probability that we don't roll a 7 or a 9? In other words, what's the probability that when we roll the dice, we don't go bankrupt? Well, if A is an event, then the probability of not A, in other words, the probability that A does not happen, is 1 minus the probability of A. This is a formula we use to calculate probabilities involving not. So in other words, the probability that A does not happen is 1 minus the probability of A. The probability that we roll a 7 or a 9 is 10 out of 36. So the probability that we don't roll a 7 or a 9 is, can you figure out what that's going to be? It's going to be 1 minus 10 out of 36. In other words, it's 36 out of 36 minus 10 out of 36, which turns out to be 26 out of 36.